Hey guys, welcome to Science at Home. So in today's activity, we're going to be talking about eclipses. I'm going to show you a PowerPoint, but this could be one of those times where I'm going to say you don't have to take notes as long as you can do this afterwards. So I can explain, that's your action, how an eclipse happens. So we're going to go over what an eclipse is in the PowerPoint. And really what I want you to explain is how a smaller object can block our view of a larger object. So in this video, I'm also going to do an activity, and I want to see if you can replicate that activity at home. Okay, so let's start off with watching the PowerPoint. So today's lesson's about solar and lunar eclipses. Solar means sun, lunar means moon. But what does eclipse mean? So again, the option is yours to take notes today. I'm not checking on your notes. I always think it's great if you are taking notes, and it helps you finish up those I can statements of explaining how an eclipse happens. So it would be great if you took notes. So an eclipse occurs when one object blocks your view of another object. So from Earth, okay, we're talking about what do we see in the sky that could possibly be blocked? And then what could block our view? Okay, of course, clouds can sometimes block our view of the sun, block our view of the moon, block our view of the stars, but we don't typically refer to clouds as causing an eclipse, just so we're clear on that. Okay, so from Earth, we routinely experience two kinds of eclipses. An eclipse of the sun, that means our view of the sun is blocked, or an eclipse of the moon. And again, that's our view of the moon is blocked. So starting with a solar eclipse. Okay, so from Earth, you look out during the day, you see the sun, of course, unless there's clouds. Okay, but if another object, somewhat more solid like the moon, were to come perfectly in line between us and the sun, we wouldn't be able to see it for a small little bit of time. So I have two other vocab words up here, umbra and penumbra. Those are terms used for the darkness of the shadow. So I don't know if you've ever gone out at night and like a street lamp shining down. There's some areas where the light is very bright where it's shining, and other areas not so much. Or sometimes you see an overlap of the light. So thinking now in the opposite of that, shadow, where there's a really dark shadow because no light's getting through, that's your umbra. But then there's what we call a lighter shadow, because a little bit of light comes through, because a little bit of light from here is coming through, but yet this much of the light is being blocked. You get what we call a lighter shadow, and that's the penumbra. This is what you end up seeing when the moon is blocking the sun. This actually is, just look how dark that is, that center there, that's the moon. And you get this ring of the sun just around the outside. Now, when you have a total eclipse, this one seems to be just a partial, because I still see a good amount of the sun showing. You can have a total, and it depends on the distance of the moon and the sun from each other when we see them. Oh, by the way, you have to wear special glasses if ever you are looking at a solar eclipse. Just like you're not supposed to look at the sun, you wouldn't be able to look at that either. So the eclipses have different names. Partial eclipse, that means only part of the sun is actually blocked by the moon. A total eclipse. And then what we call an annular eclipse, which I think that past one that previous photo would be one of those. Okay, now a lunar eclipse. They are a little more common, and when they occur, more people can see them. So with a solar eclipse, it's just a little line that goes across the globe, and I mean, it happens quickly, and you have to be in the right exact spot. Lunar eclipse, we can say, well, all of North America can see this lunar eclipse if we tell everyone the time to look. And this is an eclipse of the moon, okay? When the view of the moon is blocked by Earth. So you can see that in this diagram. You have the sun, Earth, and then the moon. And the whole time the moon is passing through this area, we're having an eclipse. It continues over here too, but you start to see a little bit more of the moon, or at least the color changes. And it becomes like this brightish red because of the bending of the light. Just like that. Maybe more orange than red. Okay, so here was someone who had set up their camera, didn't move the camera, and had taken several photographs one evening during a lunar eclipse. So when I was mentioning before, I'm going to move my picture up now out of the way. Let's try that again. Okay. So when you have an eclipse, I was saying not everyone can see it. So here, the United States and South America could not see that eclipse. But this whole area that's shaded in, they saw the eclipse. Okay? So not everyone can always see them. You would have to check it out with the news and see exactly what happens. And I found a funny cartoon. So now I'm going to explain an activity to you. I'm going to take it outside, and I want to see if you guys can set it up at home. I don't give answers, but I do clearly explain how to recreate it at home. And the focus is trying to understand, especially if I go back in my slides and think about it, how can the moon, which is so much smaller than the sun, block our view of the sun? So I want you to think about that. That's the challenging question. And then I'll have you guys type in your answers on a Google Doc. So in this activity, we're trying to figure out how an object like the moon could possibly block our view of something so large like the sun. So what you need for this activity will be some scrap pieces of paper. We're going to tape them together. A very large pot, or just the lid of it. I'm going to go with just the lid. Okay. A couple of markers. I'm going to use red for the sun. I'm actually going to use blue. Depends on whatever color you found, but a smaller one to be the moon. Okay. Pair of scissors, tape, index card, and saran wrap. And I'll show you how we're going to do this. So first thing I'm going to do is I have 3 scrap pieces of paper. First thing I'm going to do is figure out how to orient this paper so that I can draw this whole lid on top of it. So I keep trying to see how this fits best together before I tape it all together. There we go. I think that works. So I'm going to trace this now, this round shape right on there. And since this is representing my sun, I'm actually going to trace it with the red marker and then color it in. I will fast forward this video because you really don't need to see me coloring it this whole time. You also don't have to color in the whole thing, but that'll be enough for me to be able to see what we're doing. Now the other item, I'm actually going to use the cap of this too. This will be my moon, and I'm just going to draw around the cap. And there we go. And there's the moon. So much smaller. So much smaller. Okay, the next thing we're going to do is we're going to cut a little window in this. Show you how I do that. I fold it in half. There you go. What we're going to do is also cut out our moon. But dropping it. But I don't want any paper around it, so I'm actually cutting it totally out. Okay. Next thing I'm going to do is I'm going to put some saran wrap right across this. I'm going to tape that on there. First I have to cut out the size that I need. There we go. Try and keep it as clear as possible. And you don't want any of the tape across here because actually the tape will block out the light that we want to pass through. So we want to try to keep the tape off to the sides wherever the white is. Or I just now had it all cling to itself without any tape on there. But we have to tape our moon on. Now, I've already done this once before, and then I misplaced the video, so I'm doing it again. But I found out if I tape like this, all that space where the tape is affects what I'm trying to do. So we really have to fold over the tape so it hides behind our model of the moon. It has to hide behind it, so I'm folding it over really small. And I'm going to stick that right on there. So there's my moon. Okay, there's my moon, and you can't really see the tape. Okay, I'm now going to set this up outside, and I'll show you what we're doing. Okay, so here we are outside, and I have the sun that I have taped to my shed, and I've got the moon. Let's see if I can't drop things right here in this clear little window. And we're going to see if we can get the moon to block our view of the sun like it does in an eclipse. So let me turn the camera around. So here's our moon. It's so much smaller than the sun. Of course it won't block it. But I'm going to take some steps backwards now. And I'm going to move further away from the sun. The moon is still going to be close nearby me. But I'm moving further from the sun. Let's see what happens now. Almost. Let's see, I'm going to get further from the sun. Keep in mind, we're trying to solve the mystery of how something as small as the moon could block our view of the sun. Oh my goodness, look at that. So I want you to try setting up this model at home and tell me how many steps it took for you to get from the sun so that the moon was able to cover your view of the sun. How many steps did that take? And why does that happen? Explain to me in a Google Doc.